Take a look on another control chart called NP chart. NP mean non-conformity product or non-conformity proportions, you can call it. This is coming from attribute or discrete data type. And when you have a attribute data, discrete data, and defective data, NP chart is used. So NP chart and P chart, P stands for proportion chart. These two charts can be interchangeably used for these two conditions. One you have a defective, one you have attribute or discrete data set. So when you say control chart comes from this has control limits, right? So when you say control limit in this very example, so you can see here the NP is 6 and the upper is 13, and whenever the negative value we get it, theoretically we need to assume as 0. What is the formula? Formula is a very straightforward formula. So the formula for this one is that first we need to determine NP. NP is nothing but the number of proportion, right? So number of proportion is sum of defective divided by count. For example, whatever the defective you have. For example, in this case, I have 154 defects and divided by 25 samples. So this is 25 samples. That will give you the NP percentage. Right? From there, you can directly substitute NP and UCL equal to NP bar plus 3 square root of NP 1 minus P bar. P is proportion, and that we have seen it even in the proportion chart. And then the same thing, if you apply minus, it becomes lower control limit. And then the beauty is that whenever you update this one, and all you need to do is that automatically the limits get calculated, and only thing is you have to update these two. One is sample size inspected and a defective one. With that, the P bar, NP bar, LCL, UCL, subgroup, everything will get calculated based on this. So with this one, we can create beautiful control chart called NP chart. With that, we have completed all four chart of attribute. Like we have covered C chart, U chart, P chart, and now NP chart also as well. And more in detail, I'm going to cover in upcoming videos. Thank you so much. Stay tuned.